This lesson's on permutations. It's from chapter 6, lesson 2. And you need to be, a permutation is an order, an arrangement of items where the order is important. And you have to be able to count how many ways you can do something when you're doing probability, because since probability is the number of ways you want something to happen compared to the number of ways it can happen, you have to be able to count the number of ways that something can happen in order to figure out the probability that it actually will happen the way you want it to. In permutations, a capital P stands for the word permutation. A lowercase n stands for the number of items or things or people or whatever that that's in the whole set that you're choosing from. And R represents the number of things that you're going to pick. Like you might pick 3 out of 20. Or you might say, how many ways can I make a batting order of 9 players from a roster of 12? So the permutation would be the number of ways that you can make a batting order. And it's a permutation because when you're putting out a batting order, the order matters. And N would be 12, the number of people on the roster. And R would be 9, because you're going to pick 9 out of 12. Or if you had 6 people to choose from to make a relay team, of course you have 4 people on a relay team. The number of ways that you could put together that relay team where it's important for who does the first leg, second leg, third leg, and anchor leg, that order is important. So that's a permutation. N would be 6 and R would be 4. This way of putting those things together would be read as a permutation of n things taken R at a time. So there's n things to pick from, but you're only going to pick R of them. So this would mean there are 6 things and you're going to pick 4 of them. So let's talk about how you calculate how many ways you can do that. There's a logical, reasoning way to do this, and there's a formula. And I think if you had to pick one way of really understanding it, would be the logical way that you can think through this. If you forget the formula, it's not hard to figure out how this works. If you're going to pick 4 things, you're going to have 4 slots for the things that you're going to pick. When you're trying to figure out who's going to run, if this was that example of there are 6 girls and you're going to pick 4 of them to run a relay race. When you're deciding who can run the first leg, you've got 6 people to choose from. If you pick that girl, there's only 5 left for the second leg, and then 4, and then 3, and now we're using the fundamental counting principle that we studied in lesson 1, where you have categories of things, where you have legs, first leg, second leg, third leg, fourth leg. The number of ways that you can pick or put them together is a product of the number of choices you have in each set. So you have 6 choices, then 5, then 4, then 3. So this would be 30 times 12, or 360 ways that you could put together a relay team. Pretty incredible that there's that many ways you could pick when you have 6 people. But if order didn't matter, you wouldn't have near that many ways of choosing. But because order is important, there's actually more ways to do this. Let's suppose you are in a class of 20 people, and you wanted to choose a president, vice president, and treasurer. So you're going to pick 3, and let's say that one person can't hold more than one office. So if you elect a president, then that person's not eligible to be vice president or secretary. So if you wanted to figure out how many different ways that could happen, it would be a permutation of 20 things taking 3 at a time. And that would be, you got the president, the vice president, and the secretary. I think I said secretary and treasurer, it doesn't really matter. So you can pick out of 20 people for the first office, and then 19, and then 18. And if you multiply them all together, you get 380 here, and then 18 times 380, I actually figured this out ahead of time, was 6,840. So again, a pretty astounding number of ways that you could pick just 3 people to hold 3 different offices when you have a choice of 20 to a field of 20 that you can choose from. Now I mentioned there is a formula for this, and I want to introduce that to you. There's also a pretty similar way to do this on a TI-34, which I'll show you in class. The formula says that a permutation of n things r at a time is equal to the number of, that looks like an exclamation point, but in mathematics that stands for factorial. So that would be Well, let me give an example. Let's write the formula down. And then you have to do an n minus r, and then do a factorial of that. Factorial is just, if we use a simple example, 3 factorial would be 3 times 2 times 1. So you start with n, then you multiply by n minus 1, then n minus 2, then n minus 3 until you get down to 1. So 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And of course you don't have to put the times 1 there because it won't change the product. But that's what factorial means. So let's take this example, and you'll see why it works just to do 20 times 19 times 18. Well, I think I want to use the first example here. To do that, it's going to take a long time to show that one. So let's do the permutation of 6 things 4 at a time. So if I apply the formula, n factorial, n would be 6, would be 6 times 5 times 4 times 3 times 2 times 1. N minus r factorial would be 6 minus 4 factorial, and then you have to simplify things in parentheses first. 6 minus 4 is 2, so that would be 2 factorial. So I would have 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial, 2 times 1. And then this would cancel out, leaving me with 6 times 5 times 4 times 3. Should be, again, the 30 times 12. So this takes me right back to, I had 4 slots to fill. And in the first slot I had 6 choices, then 5, then 4, then 3. So that formula of n factorial over n minus r factorial, you can reason your way through this saying, if I have 7 books to put on a shelf, I've got 7 books to choose from, and I'm going to put 5 of them on a shelf. And order is going to matter. For some reason, say order does matter. I don't know why it would, but because when I make it a permutation, I'm going to say order matters. So 7 things, 5 at a time. When I put my first book, I'm choosing from 7. Then I've got 6 left. Remember, when I pick 5 of them, this would be if I pick 2. Then there's 3, and 4, and then 5. So this represents 7 things, taken 5 at a time, which is what this says. If I wanted to use a formula, I'd have to extend that, and then do 7 minus 5 factorial. 7 minus 5 is 2, so it would be 2 times 1 again. Puts me right back where I started. Then you could probably either do this pencil and paper, or you punch in a calculator, but if you're using pencil and paper, look for combinations that make it easy, like this is 30, 30 times 4 is 120, 7 times 3 is 21, so you could do 21 times 120 in pencil and paper and save yourself a lot of time. That pretty well covers what I wanted to introduce to you about permutations. There is, I think I mentioned, there's one other more complicated kind of thing in your book that I want to talk to you about in class, in addition to showing you how to do permutations on a calculator. And if you're curious about what's more complicated, it's described in the bottom of your book where you're trying to put, about on page 134, where there's a set of 2 green marbles and 2 blue marbles, and you want to have any different arrangements you can make of 2 greens and 2 blues. And the tricky part about that is that one green is the same as another green, so that you have four things, but 2 of them are really not there's 2 pairs that are not different from each other, so that gets a little more complicated. I'd rather cover that in class. Thanks.